let me start from simply describing what is iBasis is. iBasis is about 20-year-old company, started from the garage of one of the founders to build the voice over IP network across the globe. The goal was to enable our customers, major telcos and smaller telcos, to intercommunicate between them more efficiently and more cost effectively. Think about very simple use case. You pick up your phone at home and trying to call your friend and friends. In this case, your company, let's say Verizon, will try to send the call to a company like iBasis. There are quite a few of those. And iBasis, having our algorithms to do least cost routing, will help to transfer this call efficiently with a good quality and a low cost to another side to friends. So obviously, any operator, being it AT&T or the smaller carrier, will need to spend much more efforts to interconnect with all the different telecom carriers around the globe. It's about 2,000 carriers, so it's a lot of work. So a company like iBasis is in a business to help carriers to achieve the more scale, lower cost, and deliver the value in the middle. So we are the high volume and low margin business. So in our case, the cost and efficiency and speed is a key. If we are not efficient identifying any issues, we may lose a lot of money. So obviously, over the years, our business grew. We started to be more prominent in the voice business. So we have multiple product offerings. We're looking at the fraud. We can identify fraud patterns, and we'll help our customers to block those calls. We do analytics around quality and margin distribution between our carriers. We're also in the business of the mobile interconnection. So think about the case where you're traveling internationally. Your phone needs to keep connected to the network while roaming in another country. So we provide a lot of those services as well. We're also in the business of SMS transfer. So basically, everything that is international bounded, it's our business. A little bit about statistics. As I said, we are high volume, so we're processing about 2.5 billion transactions a day. Think about sending SMS messages, sending voice calls, signaling, and so on. We keep data in about 200 terabytes IBM Netezza storage, a data warehouse. Our system processing roughly 13,000 queries running from multiple systems, from different sources, serving our internal users and our customers. And we're trying to make a goal to keep average query runtime less than 5 seconds. What that means that majority of the queries are finishing significantly less time, 1 to 2 seconds, but there is significantly longer query that may run maybe for 5-10 minutes, but altogether it's an average of 5 seconds. Our use case, when we started our journey to see how we can do better in terms of delivering faster analysis to our business and to our customers, we saw that looking at a couple of other carriers, that WebAction is really very well positioned for us to achieve fast delivery of the data with a significantly lower time to build stuff. And you will see it throughout the presentation how. Let me explain what is a GRX and LTE. LTE is probably more familiar for you. It's a 4G networks. So of course, when you're trying to roam in another country, once you're getting to, let's say, airport in France, you will be prompted to see, actually not prompted, you will be trying to connect to a company like Telecom France. And of course, Telecom France will try to authenticate you with your home operator. And if it's all good and you have a roaming agreement, you will be authorized to work and roam in that country. In order to achieve that roaming, a lot of work is done by iBasis to integrate between all the carriers around the world. Today we have a coverage in about 640 networks, so company just need to connect to iBasis, and the rest will be handled by us, delivering the smooth user experience in another country. So our goal is to ensure very consistent network performance in the other country and deliver high-speed mobile data experience, which is very important for us. So what is a use case? Being a network, being real time, we do expect to monitor our network throughout the 24/7 time frame, and we want to identify issues on our networks, both performance and cost related, as soon as possible. As I said, it's a high volume, low margin business. We need to be very efficient. In order to deliver that, we can simply look, like Steve pointed before, at the certain event and immediately escalate it for the analysis, but it's a lot of waste for our network team to do that because they will get a lot of noise. So what we are trying to do, we are trying to do smart stuff where we're looking at the patterns of the traffic, compare those patterns with what is the expected performance should be, And only if it's a continuing problem that is not self-recoverable, like in most of those cases, then we'll try to speed it up and present to the network operational control for further analysis. So make a simple example. If I get six if I get 6 issues within the last 30 minutes, then it's a time to alarm. I don't want to alarm on something that has maybe just disappeared after first event. So the power of WebAction is exactly to address not just the analysis of the data that is coming in, but also look at it in a time window. It's called sliding window or jumping window to identify the pattern, and only when everything that should happen happened, only then to alarm. Really beautifully work with WebAction. Together with that, we also need to provide an availability of data right there. So our network team can immediately look at the alarm together with reasons for that alarm. So what are the trends? How the data actually changed? What are the signals that caused it? We want it to be really efficient. Third one, as any one of developers here probably would attend, that today's requirements from the business is to fast changes. Agile is a buzzword, but in reality, everyone wants to get changes done very fast, especially in a new product like this one. We know that we built something initially. We know it will change significantly in the next, let's say, half a year to a year. So we need to make a solution that is easy to adapt. So how would you do it before? Obviously, majority of you are probably familiar with the old school of doing ETLs. You would get the data, you will process it through the systems, you will probably need to land it somewhere for the further analysis. So you will need to store it in the database. You will then need, because we will compare with a baseline, we'll need to pull the aggregated level data from the history, let's say last 30 days, identify the trends, and store it for the compare later on. Then we'll need to do the most significant part of program here, is to create a process that take on one side the data that represent current performance analysis, take the threshold baselines that we defined in a step number 2, and compare and correlate, and once certain events happened, to alarm. Of course, we need to store this data to be accessible throughout other systems for monitoring. And the last step is to build the dashboard that will access the data generated in step 3 and expect to get more information along with that for trending analysis. Not a big deal, we all do it, but there is a simpler way to do it. All you want to do, you want to simply acquire a new data set. You want it to make simple. Just point to the file location and let the data stream in. Once the data stream in, you want to keep it in your memory, readily available for processing later on. And second step, to generate your baseline based on the previous period of time, and also put it in what considered to be pipe, right? So you have concurrently running 2 pipes, one with the current data, one with the threshold data. All you do, you simply put now in the step 3, compare on a window. So you're saying in the last hour of the processing of my current data, and I have also the baseline, what are the deviations from the norm? So you identify those deviations. In my case, let's say 6 deviations from the norm in the last hour. So the two keys here is a deviation, how to identify the deviation, and the period of time. So once 2 are matching based on our algorithm, we will then create an alarm. Very simple, very logical in a normal human sense, and it's easily done in the tool. So the key concepts here are streams. The data is flying in, and window, the data is captured in a certain period of time. Once you have those 2 key pieces, you can do with this data a lot, and the beauty of it, you can do it like an SQL. And the other nice tool, not nice part of the functionality is you can build dashboards or build reports and other data analysis right on the data itself. On the same data that's running through your pipe, you can analyze it as it comes available. I'll probably show it to you in the next slide. You can see how it's done. Now, why we decided to embark on this solution? So we have pretty advanced approach to analytics. We have Netezza appliance. We have other tools that help us to analyze data fairly efficiently. So we can get the data on our network that happened about hour and a half before. But it's a lot of time. So we were good in this situation for like 6 or 7 years. But we quickly realized in the last couple of years that to get insights on what's current, what's happened in the last 5 minutes, the last hour, is very important, because in this last hour, we can lose a lot of money. So we started to improve our roadmap and build an infrastructure that will basically split our analytics into 2. Online, it's the last 2 hours. Offline, it's before. So of course, it's a lot of value for offline, but it's something that you cannot affect. What you really can affect is the data that happened just now in the last 5-10 minutes, because it's become data that operationally you can make some changes. So yes, maybe you will lose something in 5 minutes, but you can immediately recover in the next 5, and you can affect significantly both margin and quality. And quality perception in the network business is a very simple, important. Company may see you not operating well, it will switch to gain the business back. So as much as it's maybe considered minor, the first piece here is very important for us. And we looked at the technologies that are fairly advanced and convenient for us to use, while it should be also simple and effective. So the approach we took, we just decided to put something that processing data right as soon as it's become available, analyzing for operational needs only, throughout some decision making or some notification to our network operational team. And then we simply take the data forward, move it to the data warehouse, do further enrichment, processing, and it's become available through our normal process. So the position of the net of web action is right on the top. How we see the flow of the service. We acquire data from our routers, from the network. We immediately load this data into web action cluster. The web action cluster helps us to basically identify the alarms. Once alarm is being identified, we send it to network operational control. At the same time, those network specialists can look at the data as it's become available, and you will see the examples later on. So they can start analysis right away and then go to more detailed data and make changes itself. Once we address that issue, which is the most priority for us, we can then push the data further through the enrichment process to the data warehouse, and then go as a normal process to build reports, to build analytics, and so on. So the key initial use cases that we've built is, I believe, probably those 7. So the first point is that your data is loaded directly into web action. So there is no overhead of a storage time and the processing time. The data becomes immediately available. And you will see in the next slide how easy it is to get the new data set loaded. The data can be stored in memory, or the data can be loaded into the Elasticsearch or into the database. It can be done in the first stage, or it can be done at the last stage. It's really good CEP alternative. CEP nowadays, and we looked at a number of alternatives, it's a mostly very complex development, being Java, being some other technologies. And today, my team is not a Java team in this business intelligence. It's a very good, skilled people that are familiar with business object, Oracle Data Integrator, Tableau, and others, but there's no Java set of skills. We don't want to engage in this pattern right now. We want to basically find the solution that is very intuitive, very simple for us to use, leveraging the knowledge and business practices we have today. So that's why it's become really more interesting for us to do that. To have both data intake, processing of the data, and analytics on top of it, it's a really compelling advantage for us, because everything done at once, you simply save time and efforts on building 3 different components: loading part, processing part, and the presentation part. It's all done at once. Like I mentioned before, you can do the development in the user interface, or you can do it in the TQL language. TQL language you're going to see in a few slides after that. It's a like SQL example. For people with experience in SQL, it's no-brainer. You can really build applications literally in hours or days, depending on complexity. And the beauty of it, you can expand it, and it's really become simple. The solution that I'm talking here is about 400 lines of code. That's it. It's very important, of course, to be able to extract the data to external systems, and the web action provides a RESTful API, which allows us to extract the data to other systems and subscribe to the services. Of course, web action provides a solution for scaling up, and it's a cluster, so you can add the two servers, or you can expand it further, so it's pretty robust. And nice, but something that exists for a lot of tools today, the ability to simply put an agent on your source of the data, being it router or being it something else, and simply start pulling the data into web action cluster seamlessly. I'll show you a quick example of the tool. Okay, I can't do Zoom. So what you see here is results of the web action dashboard. You see on the top a bunch of alarms that have been generated in the last couple of hours. And what you see clearly here is that once I select one of those alarms, you have a baseline in green. And suddenly, from this point on, we identify an issue. So something is not performing well. In this case, it's a number of successful transactions are failing. So here's the expected baseline. Here's where we are. After those 6 events, alarm been triggered. Alarm been triggered, the record been added to the screen, trend analysis is available right underneath. So it's very easy and efficient for the network operational team to investigate the alarm. They can click right there and go to another systems that have more details and operational solution to solve the issue. So from the moment we identify the problem to the moment of resolution may take 5 minutes, because it's a high priority alarms and be it set up, being alerted, and the action can be taken. Very easy and very efficient. Another example, within the same tool, we're looking not just on the success ratios, but also on the volume degradation. So if you suddenly see that we don't have enough traffic compared to what we expect to have at the period of time, the line goes underneath, like patient dead, we'll also alarm. So within the same process, we have multiple ways to alarm and trigger certain events. Now to the code, maybe more complex part, but really what's convenient here is the simplicity. You can see that first part is just defining the types. It's a complex type of multiple KPIs connected to certain MNO, mobile network to mobile network connectivity. We define the stream. Stream is considered it's a pipe that's getting data in. Right after that, you can see right there, we simply connect it to the file location, to the file folder, to the folder with a bunch of files with a wildcard, defining certain attributes of the files, and starting to stream this data into the streams that we just defined. Very simple. So think about it, the data kind of available in the table, but the table is constantly changing because the data is changing in this table as time goes through. Another example, we can pull data into cache. So on one side, we stream FAG data. On the other side, we need to pull the data from our table so we can do some aggregates and create a baseline. In this case, we also create a type of the data, bunch of KPIs for certain dimensions. And for this data, we define connection to the Oracle database in this case and get the KPIs that we need to use. So what we created just now is 2 pipes. One pipe is getting the data from the network. It's a current performance statistics. Second pipe, or cache, is the data that should be measured against. So any deviation from the current performance to the baseline will be identified as a violation and will be triggering alarm eventually. Comments, questions? All right. Next one is a bit more complex. I'll try to simply skim through. Everything, again, is about types. Like you probably know that nothing is simple in terms of data management. So you identify certain type. In this case, it's, again, certain data stream from certain carrier to certain carrier with some KPIs. You aggregate the data on the hourly interval. So this is your window of an hour. So data that getting in, being stored for an hour, and being analyzed and compared with a baseline. And as soon as this 1 hour moves on and there's no interesting events, the data has been just ignored. Okay? In this case, you do simple insert statement from one stream to another, and you do some enrichment, by the way. You can basically look at some success. You define basically as a success ratio in this case. How many successful transactions compared to the total number of transactions. Fairly simple. This application by itself is not a rocket science. There is no like advanced statistics, but it's a nice and simple way to automate what person normally would do, or some other more complex program would do. Identify number of events in a certain moving window, and as soon as certain events happen, to alarm on that. Further down, we also do some additional analysis and aggregation, trying to identify which of the events that we just passing through are interesting for us. Interesting event is kind of an outlier, something out of the norm. Out of the norm is a case where you have something violating the thresholds right there. So if it's violating our thresholds, we'll put it into the separate table for further processing. So it's like step-by-step analysis of the data as the data coming through. And the last step, as we identify those alarms, we'll just put it in a separate stream. This stream, as any other stream, is available for the reporting. So first of all, we'll analyze the stream. As soon as 6 alarms, in this case, happened in a 1 hour interval, we'll start an alarm. Alarm is just a few lines of a command to generate and send to our operational systems. Now, the same data now can be accessed directly from the memory in the dashboard. This is very nice and easy way to approach the data. You don't need to store it in addition. You don't need to move it around. The data that you just generated, immediately available and refreshed on the screen. So think about user experience where you have a big screen that suddenly a new line just dropped in. You've been alerted. You can now make an action and solve it. Just a few slides, maybe actually one about the UI part. There is a way, of course, to do the visual interactions, and you can build those nice, complex, or simple flows. It's a way to do it. I personally have like a lot of technical skills. I prefer to do TQL. But again, it's up to the persons that work with it. You can do it the one way, and you can do it another way. This was done in a TQL. It's still been transformed by web action into the nicely presentable view that you can, if you follow it, you can get sense of what actually application is doing.